Welcome to A2 Further Programming. At AS level, your code ran from top to bottom and forgot everything the moment it closed. In this unit, we change that entirely. You will build software that permanently remembers data, handles its own runtime errors without crashing, and executes multiple tasks at exactly the same time. This is where you transition from writing simple scripts to engineering robust professional systems, preparing you for both Paper 3 theory and your Paper 4 practical exam.
First up is recursion. Instead of using standard iterative loops, a recursive subroutine solves a problem by calling a new instance of itself. You will trace call stacks for classic algorithms like factorial, Fibonacci, and complex tree traversals. Recursion is a massive part of your Paper 4 programming exam, requiring you to carefully define base cases so your program knows when to stop rather than spiraling into an infinite loop.
Next, we tackle exception handling. When a user types a word instead of a number, a fragile program simply crashes. You will learn to use structured try-catch blocks to intercept these runtime errors, handle them gracefully, and keep the system running. We will even build custom exceptions so your object-oriented code can flag highly specific business logic failures, like an invalid bank withdrawal or a missing database file.
Variables in RAM are wiped the moment the power cuts. To make data persist, you need file processing. We will cover sequential text files for readable data like CSVs and then move to advanced binary files. Binary files allow random access, meaning you can jump instantly to a specific byte offset to read or update a fixed-length record. This is the silent workhorse behind modern databases and efficient storage systems.
You will also master the 4 standard algorithms that form the backbone of computer science. These are linear search, binary search, bubble sort, and insertion sort. You need to be able to write these from scratch in both Cambridge pseudocode and Python, trace their execution line by line using trace tables, and evaluate which algorithm is the most efficient choice for a given dataset.
Finally, we explore concurrent programming. Modern software rarely does just one thing at a time. You will learn how operating systems manage multiple threads, the critical difference between concurrency and true parallelism, and how shared memory can cause dangerous race conditions. This is strictly a Paper 3 theory topic, where you will use binary and counting semaphores to synchronize shared resources and prevent system deadlocks.
To sum up, this unit elevates your programming from basic scripts to professional-grade software. You are going to write elegant recursive functions, handle runtime exceptions without crashing, read and write persistent binary files, implement standard algorithms, and trace concurrent threads using semaphores. When you are ready, let's get started.